we'll look at how we can use our x-intercepts to help us factor. So we've just finished looking at solving equations using factoring and the zero product principle. So I go through an example here with you. So solving that quadratic equation, we factor it, set each factor to equal to 0, and then we get our solutions. So if we look at how are the solutions of x squared minus 4x minus 6 equals 0, so those solutions, meaning 6 and negative 2, how are they related to the graph of x squared minus 4x minus 12? So the graph is given here. So we can see the scale is 1, so 1, 2, 3, 4, 5, 6. We notice that one of the x-intercepts is at 6, and the other one is over here at negative 2. Well, aren't positive 6 and negative 2 the solutions to the equation? So how are the solutions of that equation related to the graph? Notice that the only difference between the equation here and the equation here is that in place of 0, we have a y, or vice versa. So basically what that's saying is, where does y equal 0? That happens when x equals 6 or negative 2. So the solutions are the x-intercepts, 6, 0, and negative 2, 0. Okay, so the major point here that I don't want to gloss over, the x-intercepts of a graph tell you the solutions to when the equation or expression equals 0. So that answer implies that if we know the x-intercepts or the solutions of f of x, we may work backwards to write the factor form of the function. So if we know that x equals 6 and x equals negative 2, so we graphed our expression, so we graphed y equals x squared minus 4x minus 12, and we see that 6 and negative 2 are the x-intercepts, so this is what we know. How do we work backwards? Well, think about going backwards from here up to the previous step. So the goal is, if we start here and work our way backwards step by step, we can end up with the original equation. Okay, so if we know x equals 6 is an x-intercept, or a solution when the equation equals 0, we know that x minus 6 equals 0 was that previous step. If x equals negative 2 was the solution, we know that x plus 2 was the previous step. And that step, going backwards, told us the factors. Okay, so we can use x minus 6 as the factor, and then x plus 2 as the other factor. So we know that that is the factored form of our graph that we're given. All right, so just to do a few examples here, we're going to write the factored form in the standard form of an expression whose x-intercepts are the following. So if we know that x equals 3 and x equals 7 are the x-intercepts, what was the previous step? So think about what would the factor have been. Well, we know the factor for x equals 3 would have been x minus 3. And then for the 7, notice that x minus 7. So basically, subtract 3 and subtract 7. You get x minus 3 and x minus 7. That told us that that step before that would have been the factors of x minus 3 and x minus 7. So that would be the factored form. And then the standard form would be, if you FOIL that out, you get x squared minus 10x plus 21. So that would be the standard form of that equation. Okay, so if you try the next two, I'll point out that x equals 0. That one's a little bit trickier. Okay, but I think you can handle it. So I'll pause the video and try those, and I'll put the answers up. Okay, so with the x equals 0, that told you that you had a GCF out in front. Now technically, you could think about that as x minus 0 equals 0. Well, that means x minus 0 is just x. Okay, so if that helps to think about it that way, that's fine. Okay, and then moving on to the second page. Okay, if you want to solve the quantity 2x minus 1 times 3x plus 1 equals 0, just like before, you apply the zero product principle. You set each of the factors equal to 0, and then solving them, you get rid of the subtracting or adding first, and then you do the division. So you get x equals positive 1/2 and x equals negative 1/3. And I want to point out that notice that your solutions here are the opposite sign from where you started with, and that will always happen. You'll get the opposite sign as where you started. Okay, and notice that on the graph, positive 1/2, and just be careful of the scaling here. I have this zoomed in, so this is positive 0.5 right here. That's one x-intercept. Negative 0.5 is right here. So you can see that negative 1/3 makes sense right about here. Okay, so those are your two x-intercepts. Now the reason I want you to look at that is, remember that if we know the x-intercept, we're working our way backwards. So if we knew x equaled 1/2 was a x-intercept, to work your way backwards, where did that dividing by 2 come from? That came from multiplying the x by 2. So you would have to go backwards, multiply by 2. That would give you 2x equals 1, and then subtract 1 to make 2x minus 1 equals 0. So that's working backwards. Okay, so if we have x equals 1/2 and x equals negative 7, if those are solutions, meaning the x-intercepts of our graph, how do we write that? In factored form and then standard form. So if x equals 1/2, work your way backwards. That dividing by 2 came from multiplying by 2. So you go backwards. And then how do you get rid of that equals 1? You have to subtract 1 from each side. Okay, so 2x minus 1, that's one factor. And then the x equals negative 7 gives you x plus 7 as that second factor. So there is the factored form of that equation. Now, I didn't say how to express it as standard or factored form, so we can just leave it as the factored form. Okay, and then the next one, if x equals negative 2/3 and x equals 3/4. Okay, this is a trickier one. To get rid of that dividing by 3 meant you were multiplying by 3. And then how do you get rid of subtracting 2 or negative 2? You have to add 2 to that side. So 3x plus 2 equals 0. That'll tell you that 3x plus 2 is one of your factors. Same idea for 3/4. Multiply by 4. And again, if you get confused by that, remember the idea is if you had 4x equals 3, wouldn't you divide by 4 to solve for x to get 3/4? Now we're just going the opposite direction. So that gives you 4x minus 3 equals 0, which meant that 4x minus 3 was your second factor. Okay, and then the last few, I want you to write an equation in factored and standard form for the following graphs. So this is just giving you basically two x-intercepts. So look over here and here. Find the origin first. So right here is 0, 0. And then negative 1, negative 2, 3, 4, 5, 6. So negative 6 is one x-intercept, and it looks like negative 2 is the other one. Okay, so if you go through and try each of those, in the last one I'll point out that negative 0.5, treat that as negative 1/2, and work from that. So I'll put the answers up. So first you write the x-intercepts, and then it's the same thing as these other questions. Okay, once you know the x-intercepts, it's just giving you the graph first, so you have to do that extra step. Okay, so you have the x-intercepts, and then write them as factors. Okay, and then you have the factored form and the standard form. Okay, so that is using x-intercepts to help you factor a polynomial.